Welcome, everybody. Welcome. Today we've got a special guest speaker, Mr. Scott Pugsley. Anybody who's pretty much been a Seneca ever will be familiar with him. But for those of you who aren't, Mr. Scott Pugsley currently serves as a full-time professor and the industry coordinator for the School of Fire Protection and Engineering Technology within the Faculty of Applied Science and Engineering Technology at Seneca College. Scott has been involved with the fire protection industry for over 29 years. He holds a NICET Level 4 certification in water-based fire protection systems layout, 427A certificate with the College of Trades, and formal education from Seneca College's Fire Protection Engineering Technology program with honors. Currently, he's involved in several different national and international professional committees within the fire protection community, including the CFSA as their current past president, CFAA as the Ontario chapter vice president, OMFPOA as director, and seven different ULC STPs. He is an approved instructor for NFPA 13 and NFPA 25, and also provides keynote, guest speaker, and custom seminars on various fire protection and life safety subjects, just like the one he's tailored for us today. So I won't keep any of you any longer. Scott, I'm going to let you just take it away.
Great, thank you. I presume I'm not going to ask the oblivious "can you hear me" questions, because those are kind of a little bit presumptuous, so we know we're all good there. Just before I get to, I'd like this to be as interactive as possible, so if you'd like to turn your cameras on, you're welcome to. If you don't, no hard feelings. I'm kind of used to teaching to a bunch of typewritten names, but what I did just put in the chat was just some instructions. If you are going to quickly answer some of the questions that I've got, just do like a Y or an N, question mark if you wanted to have me stop to ask a physical question. And then lastly, if you wanted me to sort of repeat a statement, just put a bunch of dots and hit enter. It's a quick way for you to kind of send me a quick note, and then I can monitor all those chat streams and whatnot as we're going along. And of course, I have no problem with being interrupted with questions. And at the end of this, although it'll be said, I'm sure, a couple more times, I have no problem with trying to answer some one-on-ones for everybody as they come up. Because if you're like me, you like to ask questions mano a mano and not in front of a group. So we'll make it work either way. All right. So Matt, thanks for the introduction. Overall, lots of credentials, but I think just Fire Protecting Geek works pretty well. I've been fortunate to do a lot of different things, and I think that perspective is what will probably end up helping these types of discussions, whether it's the nuts and bolts about mechanical systems, or when I'm doing an inspection, this is happening. Those are the types of discussions I'd really like to have. And if you want to go off script or off my script, that's no problem whatsoever. The game plan today: start on time. If everything goes well after lunch, we should be out of here by about 3:30. If anybody's panicking, that's like the best joke I've got. So sorry to disappoint anybody, but that was it. That's the best thing we got. This is a streamlined presentation just for dry pipe systems, and I want to talk about sort of the requirements of NFPA 13 plus the NFPA 25 requirements, and then talk about the OFC. But this is where I've got not a blind spot necessarily, but I do so much with NFPA standards that I'd be really interested when we get into the OFC requirements to see where you think there are pros and cons, and where the biggest differences are, and where some hurdles are for you within the enforcement chain. So while many of you are Senecans and many of you have a tremendous amount of experience, sometimes we get a little bit fuzzy about the overall requirements of systems. So if we can have a generic discussion about the components, the systems, and what's sort of on screen, fantastic. There is an open invitation for the OMFPOA, as well as the York Region Group and any chapter for that matter, to schedule an in-person session. And anytime that I can have people sort of in the lab spaces, this is a great spot for us to play around with, and flow sprinklers. And if I can have you guys back here at another time, that would be amazing. So that's kind of the agenda. Any questions? This is the easy one. We should have tons of participation saying no questions. That's probably just the teacher of me. Okay, perfect. Thanks, Ryan. All right, so we know from a systems overview, there are wet, dry, deluge, and pre-action, right? Those are the four. Those are really the four big systems. And I did 5 sort of involuntarily. A lot of people will want to add glycol or glycerin, or what we would be more commonly called antifreeze systems, as one of those system types. And in fairness, it's wet, dry, deluge, pre-action, and a glycol or antifreeze system is really nothing more than a wet pipe system. It's going to have a sudden thrust and discharge of antifreeze, propylene glycol, glycerin, but after that, it's just water-based. We calculate water-based, so those are the big 4, so I don't get my fingers mixed up. Within the different system types, they all have pros and cons. They all have advantages. The piping configurations might look similar, but between, as I just flashed these across the screen, between a wet, a dry, a deluge, and even into a pre-action, building types, these illustrations were all convenient to be almost identical, but they're pretty much the piping arrangements. The high level stuff is pretty much the same. The piping arrangements, right? How I get water from one of these system control valves out to the discharging area, sprinkler, or the remote area entirely. It could be a tree, a loop, or a grid. It could even be a version of those. It could be a tree system that's added on to the back part of a grid. It could be a compound grid. For all of the design experience that I have, I could honestly say that the piping configurations, if it's calculable, and bear with me on that, if I can get a successful hydraulic calculation, there's really not that much of a restriction for piping arrangements for the basics, right? Wet systems, I could have pretty much any of these 3, all fine and dandy. It does get a little bit trickier when we start to say, well, I want to have a dry system for the shipping and receiving area only, but my entire warehouse is all wet. What do I do? And in those cases, there's nothing preventing us from adding a tail end dry, doing something at the end, and having sort of a system within a system. Those are permitted and is fairly common overall. But when we start to do that, we have to really be more thoughtful of the piping arrangements, because sometimes as I try to mix and match system types with piping arrangements, I might run into some conflicts. But for all the projects that I've done, even the most complicated ones, taking a grid and adding multiple secondary mains, sure. If it'll calc, it's all about just getting a good safety factor over to the discharging heads. So the 4 of them, right? Those are the 4 of them. An open question for the group right out of the gate is, what's going to influence your decision from wet, dry to deluge to pre-action? You throw it in the chat or just turn on your mic. What's going to influence your decision one versus another?
What you're protecting?
Yeah. And just for everybody, I'm a fan of the awkward pause, so I'll let it go a little bit longer to get some answers. So things that are going to influence the system type, seeing in the chat, temperature. Temperature is the big one. Occupancy is kind of like what you're protecting. So I'll give you kind of credit for all of those. I would say in a direct fashion, it's going to come down to the type of fire you're expecting to deal with, what type of freeze risks might be related with it, any concerns for malfunction. Not that there really is a high chance of malfunction, but for an unplanned activation, just still for the credit to fire sprinkler systems, when they're maintained right, like everything else, it's a 1 in 15 million chance that a sprinkler is just going to spontaneously open. It's more likely someone hits it with a ladder. But the system ideas, wet, dry, deluge, and pre-action, the fire type, freeze risks, unplanned activation, and then the economics. I suppose if I was spending someone else's money, I might be more inclined to say I want to have a pre-action system because it layers in perhaps even earlier detection with other detection devices. but that's going to come at a cost, both initially for the system cost, as well as the overall maintenance that might not be warranted. It's sort of like, do I need to drive a Lamborghini every day to work? You know, I might like to, but the reality is it's kind of overkill, especially when it's a 25-minute drive. The thought between all four of those does have to be given some really good consideration, and not just thinking exclusively in the world of fire protection, but we have to be certainly thinking about the building envelope, what the uses are going to be. If it's got overhead doors on the sides or the back or anywhere throughout it, you can expect to see significant temperature losses through the course of a day. And you know what, it might not be a big deal to think about, but those temperature losses, you know, this time of year, if the door is left open, that back loading dock area might be subject to unusual conditions. Or if the expectation is the door goes up and down really fast and that's it, you know, you still have to be super careful about those overall influencing factors. Don't take the location that you're in for granted. For all the work that I did in Nevada and in the Phoenix, Arizona area, we still put dry systems in parking garage in Phoenix. And I was like, you're crazy. It's 110. But for the 1 or 2 days a year that it drops down below, that's the most appropriate thing to do. But if I can get away from doing a dry system, if I can get away from doing a pre-action or deluge, I absolutely want to. They have a great place, but we don't necessarily need to be using them all the time. So this stuff's easy. We're all familiar with what wet pipe systems are. No major surprises with a wet pipe system. We know how they operate. Water flows through the system when a sprinkler operates. So, pardon the silly graphic, but as water flows through, it's going to go immediately up through the system, up through all of these risers, and it would be discharged directly out of a sprinkler head. So sprinkler opens, water goes through, everything's easy peasy. Within that particular system, we're going to have some sort of an audible alarm, could be electrical or mechanical, right? Your typical water motor gongs. But you know, the bread and butter wet pipe systems are just that. In the overall makeup of systems, trees, loops, grids, no issues. In this particular illustration, you can see that the inspector's test connection is shown off to the right here, but it's really, if you trace the piping up, they've had the inspector's test connection located at the far end of a wet pipe system. Is that a requirement? Is that a requirement to have on a wet pipe the inspector's test at the most remote, or could I put it pretty much anywhere? So a couple of direct chats are coming in to me, which is great. It's not a requirement to have it at the most remote. You can have it directly on the riser. So if the contractor wanted to have this as an auxiliary drain and inspector's test all in one unit, perfectly fine. But from the wet pipe perspective, I can have uprights and pendant sprinkler heads, no real restriction. Any type of control valve, butterfly valves, you know, OS and Ys, you know, there's this illustration kind of captures the essence of everything that has to be required. And we know how they work, right? Sprinkler head opens, even better. Sprinkler head's going to open, out comes water, and the audible alarm should be alerting the occupants that something's going on, or perhaps to a central monitoring station and letting even more people know what's going on. Right? That's, you know, what I like to call the peanut butter and jam system. Dry pipe systems are a little bit more involved. And it's honestly, I think, a little bit more involved. The piping configurations, we have one restriction that we can't be gridded. So the grid pipe system would have all of the pipes interconnected in one big super system. And the problem with the gridded system is that the time it takes to have all the air exhausted is substantial. And while there are great software tools you can use to calculate the time it takes to exhaust all the air out of a dry pipe system, traditionally it's been felt that there's just too long of a delay and we can't have that. So looking at the schematic really kind of briefly, you notice that upper floor pretty much looks the same, but this is now a necessity to have the inspector's test at the most remote branch line. And now I'm going to come back to this in a few more minutes, but this illustration it meets the requirements, but I would like to kind of just point out from a contractor's perspective that if this was right there, so if the contractor's test valve was right at that location where the cursor is now, that is suitable. The fact that it goes along the wall and down 10 feet, or maybe, you know, into another room to finally be able to discharge outside of the building, I want everyone to really understand that the requirement is to measure the time it takes for water to get to the most remote sprinkler head. So if this valve happens to be 40 feet away and 1 story down, that's really not measuring what the requirement is. The requirement is that how long does it take for water to get to this sprinkler head? So don't be surprised if you're talking to a contractor and they say, hey, this is, you know, 1 floor below, but we're going to time it with a sight glass up here. That's a reasonable request. You could have a sight glass within this piping and have somebody observe that on the commissioning day, and that's what your benchmark would be. The idea of a wet pipe system, having the inspectors test at the most remote, it's probably more that they're using it as a combination drain. That inspectors test locating it on the riser is just more convenient. All right. The inspector's test on a wet system riser is just to kind of keep that one technician, keep him or her right in that room, but it doesn't create any real problems. Okay. It's just to make sure that you've got the alarms are flowing on a wet pipe system. On a dry pipe, the most remote is to ensure that you've got water going all the way to the end. Okay. And we're just talking about the requirements of the standard. Looking at these two images back to back, they're all shown as upright sprinkler heads. They're shown as trees. The real significant change, rather, is that this room where the valve is has to be heated and lit. But that's about the only other substantial difference, mechanically speaking. Now, when you get into the smaller nuances, right, when you look beyond, you know, a heated valve room, location of the inspector's test, and maybe some of the sprinkler head restrictions, there are other restrictions for the slope of the piping. All right, you can't see the slope on the piping, but the slope of piping on dry systems is more than what you might find for anything else. Okay. So does the remote inspector's test valve on a wet pipe system help to ensure the system is completely filled? It does, but any system that's been installed recently has to have an air relief valve on it. So you're thinking of a conventional system that you might have, say, in a strip plaza or in the mall. Chances are that inspector's test is just in the riser, relieving air. For older systems, the thought was to have it at the most remote, but if you have a lot of rises and down, ups and downs, a bunch of riser nipples, or if the configuration of the system kind of goes up and down like a roller coaster, getting all the air out of your system, Dan, becomes incredibly difficult. So just sticking one inspector's test at the end and say that's going to get all the air out is it's a start, but it's not going to be the prime objective. Okay. The dry system guts, again, I'm going to try to kill the volume on this so you don't get blown out of your chairs. The dry system sequence of operations, once we have a sprinkler head operate and air pressure is depleted from within the system, right? You're going to see the system air gauge start to decline. And once that air pressure has been reduced enough, the dry valve is going to trip. Now, the whole concept behind a dry valve tripping is really just the process of the mechanical advantage or the differential principle in the valve being overcome. So if we go back to this one, right now, you'll notice that the surface area of this clapper is larger. So by having a larger surface area, I can have less pressure having to push down while I could have a higher pressure pushing up from the water source. So the whole concept of, sorry for jumping past that, the whole concept of the differential principle is by having a larger surface area for the air to push down, I could have an imbalance of less air pushing down, but still holding, 40 or 50 pounds worth of water pressure pushing up. If I had increased air pressure in the system, what's one negative that could occur? So if the maintenance people aren't paying attention, and let's say this water pressure is at 50 PSI, and for whatever reason, the maintenance person is taking the decision on their own and saying, let's put 50 pounds of air pressure in it, what is going to be the downside of having too much air in the system? So one statement, Dan's got it. You might be the class president for right answers. You're certainly going to have an increased response time or an increased time for the system to trip. The easiest way of explaining this is if I had a balloon full of 20 pounds of air and a balloon full of 100 pounds of air, which one's going to empty fastest, right? It's going to be the one that has the 20 in it. So anytime that we're dealing with these systems, we have to think about whether it's a conventional dry pipe system or one of the newer styles. So on the simple perspective, dry pipe systems are still going to operate by an individual sprinkler head. We'll have air loss throughout the sprinkler. Once that air or nitrogen is depleted, that differential principle in the actual valve will be overcome and the system will trip. And it's only the individual sprinklers. It seems a little repetitive for us to have to say this to each other, but it is the individual sprinklers that are operating that are going to be able to discharge. This illustration shows nitrogen or air. Both are completely viable options. The biggest advantage to using nitrogen, if it's available to you, is that it typically helps to reduce internal corrosion of the sprinkler system. So even while things might be maintained at a very, very high level, the longer that I can keep water out of this system, and if I can have the supervisory pressure in this piping be as dry as possible, I'm going to lessen the chance of internal corrosion, which is absolutely destroying systems. Good. That differential principle is an easy one to sort of explain, just kind of using this illustration, but it's a lot harder to pick up when we're looking at individual valves. Okay, so right now, this series of 5 valves that you're being shown are pretty much the same series of valves that I have here in the room. And whether you're looking at them on the screen or here, it's incredibly difficult to tell which valve is a conventional and which valve might be a newer style. There's lots of different ways of being able to describe that, but within each one of these, there are different ways of configuring the overall valve to make it operate better. So if I go back to this one just for a second, for a conventional valve, the giveaway is that the valve itself is going to be really, really quite wide. And with that wider valve, it helps to emphasize that differential principle in the body or in the belly of the valve. Some of the newer style valves that we're dealing with actually don't have that same type of surface to air ratio that has to be there. So this would be a conventional, this would be a conventional valve, but these next 3 are all different. Now, these next 3 all operate with a mini dry valve in a way. So off to the side in the trim, a little bit difficult to see, great if you were here, but there's like a mini dry valve and a cantilever arm that's located on the left side of the globe, on the back of the Victaulic, and then on the left side of this reliable valve also. And what it does with that sort of dry valve within a dry valve, it allows me to hold that clapper down a little bit differently. Okay, so if we're looking at this particular valve in itself, it has a typical air to water mixture held back by a clapper. But at this point, the clapper that's going to open freely is actually held in place by a pin pushing down. So by having a pin pushed down, they've essentially removed that differential principle that operates here, and it's being mechanically held down in place. And once it's mechanically being held down in place, it essentially takes that dry valve out of the body of the valve and puts it into the trim, where they've now been able to modify the actuators much differently. And these valves are now more frequently operating on a 17-to-1 ratio. So if we go back to something like this, these at most are about a 5-to-1. So 1 pound of pressure for every 5 pounds of pushing up. And with these other styles, they're all individually tailored by the manufacturer. Now, Globe is now owned by Victaulic, so you might not see very many Globe valves anymore. But that same approach is, Dan, you said it really well, that air holding down the clapper is now being sort of transitioned over to a more of a mechanical, but it's still existing, right? That dry valve is just pushed over into a smaller piece of trim. So rather than have an older style approach operate the valve, it's a 5-to-1 in a smaller portion. So it's a 5-to-1 ratio in this portion off to the side, but because it's being mechanically held down, they're able to multiply that by that lever holding it in place, and that's where you'll get the higher values. Now, can anybody think of a reason why I would want to go away from one of these conventional types to one of the newer styles? You think of a reason why I would want to do that? And it's not because they were on sale or you get a bonus by buying fancy stuff. But what do you think would be a good reason for going to stay? What would be a good reason to stay conventional or going to one of the newer types? Okay, so we're all scanning the chat. There's a statement about them being easier to use, certainly lower air pressures, less chance for dry rot. So politely, no. They're actually harder to reset. It's kind of weird to say, but the reliable one, there's 17 steps, 17 individual steps you have to go through to reset them. But if I were to go to the Tyco valve that's right beside it, so we'll look at those two just for a second. This particular valve does employ that other technique of being able to have the clapper held down by a latch, but there's 17 steps to reset this. There's about 5 here. So it's not necessarily the ease of reset that's going to come into play. And from my own experience, I have to be careful about sort of supporting one particular brand. So I guess some of them are easier to work on, but that really comes down to just how familiar the tech is, right? You'll have automotive technicians who are, they're fantastic on Mazdas, and they get into a Ford and they're not quite as familiar with it. So I think the speed of resetting is going to be a function of how familiar that technician is, how comfortable he or she is with that equipment. Just looking at the questions a little bit more, the most significant, in my own opinion, the most significant reason to go to one of the newer styles is that I'm going to require less air pressure in it, which is going to be allowing me to have the system trip faster. There are restrictions for dry system sprinkler size. So there are restrictions for how big I'm allowed to have them. The biggest restriction is the time of operation from sprinkler head opening to the valve opening. And if I can change the parameters, if I can make the sprinkler head get water faster, then I could have a slightly bigger system. So the most significant reason to go from a conventional to one of these other types is that they're going to trip faster, which means I might be able to have a system that is, 1,000 gallons of water, or sorry, 1,000 gallons in size, where the pressures might be 12 psi. And 12 psi versus 20 psi is obviously lower pressure will drain faster. And if that air gets exhausted faster, it'll trip quicker. And if the only restriction is really time, these types of valves are going to allow me to have the systems trip faster. Okay. The individual requirements per system, they also have the same air supply or nitrogen supply requirements, but this is more about getting them to trip as fast as possible. Higher pressures in the system does not prevent any rust or corrosion any differently. If you're sincerely worried about rust or corrosion in the system, there should be much greater review of the water supply, switch into a nitrogen-based product, certainly. But I've seen this MIC or that internal corrosion happen at such an aggressive level that even in some of the pipes here within my own lab have to be replaced on a fairly regular basis, because we've got a couple of dry systems that just sit empty all the time. And to my surprise, the exposure to the hard minerals from the water supply are contributing, as well as the integrity or the quality of the piping. It's hard to say quality, to be honest with you, because I'm buying it from great wholesalers, great suppliers, but sometimes you just get a bad batch of pipe and it just rusts faster. Okay. So the new systems still do require some priming water to keep water above the clapper, just really to make sure that the rubber in the clapper doesn't dry out. But it's more to just make sure that seal stays wet and it doesn't get rust building and bonding throughout it. Okay. But when you look at those photos, like, I would be hard pressed unless I gave you the clues already that they all have air lines on them. So you can see, that's a dead giveaway of a dry system in general. Right? Those are those air lines. Well, I'm just showing you all of them, but really it's the physical footprint. And we have a 6-inch dry valve that's off to the corner. It's absolutely huge. You could put 2 loaves of bread inside it and it still wouldn't touch the side. Using those conventional systems, that was really the best or only way we had to hold back water, was that mechanical differential concept there. But they've gotten a lot better. Dry systems in general, if we run through the requirements, I'm going to refer to the 2019 edition of NFPA 13. That's what this was built on. We're starting to teach to the 2022 edition already, just because we try to stay as current as possible. But dry systems still have to have pressure gauges on them. The locations, city side, system side, air supply side. If you're providing it from an air compressor or a nitrogen source, you have to have a gauge on the discharge side of your air compressor to make sure that you can monitor all the different internal pressures of your systems. That is just, again, I prefer to say it's kind of a no-brainer. I need to know the air pressures throughout my system and throughout the whole system from source all the way here. As far as an air supply goes, just keep in mind, while it's certainly not my preference, the air compressor doesn't have to be listed. I'm allowed to use shop air. So if I'm dealing with a large commercial property, an automotive facility, and they have a dry system and they want to connect the sprinkler system to shop air, they're entirely allowed to. The only requirement when it comes down to like what has to be listed and what doesn't have to be listed is that the air supply line, the actual air maintenance device, the item that controls the air pressure from my source, that has to be a listed assembly. And that's this one little part that's here. Okay, it's just, there we go. This one little line that helps regulate the air pressure going through. That's the only thing that has to be listed. Otherwise, you can get your air from wherever you choose to. Can a portable air compressor be used permanently? The air compressor doesn't have to be listed. It's supposed to be on all the time, but that's just like our expectation is that it should be on all the time. this would be a great group to ask, how many times have you seen an air compressor on a light switch? They're supposed to be hardwired. They're supposed to be installed as per their listing, if they are listed, and you can get fire protection air compressors that are, directly purpose built. But realistically, you could have it plugged in. Not a fan of it. The whole thought behind that is that it's not the reliable air pressure I need to have, is the control of it. So if the incoming air pressure up here stops, eventually this system is going to go into a low air alarm condition, and that's my trigger to have some technicians come to investigate the why part. Forcing the industry to have listed air compressors, it was thought that this might be a more reasonable way of going about the process to ensure that things are being done right. And it's only that has to be. And when the air compressor dies or runs into problems, or the light switch has been turned off, when it finally does fail, that low air alarm is going to be the thing that'll give us the best and or only indication of what's going on. Okay. While I've got this multiple valve arrangement shown on screen, it's important to also recognize that every single dry system has to have an individual air maintenance device. So we've done it in the lab because I have the ability of setting them up 100% correct. And 100% correct means that if I have 5 dry valves, you have to have 5 individual air supplies. And think of it as each of them needs to drink a little bit of air or breathe a little bit of air. And what's going to be needed for the reliable one as 17:1. What's going to be needed for this one as 17:1 will be a little bit different from this, which is at a 5:1. And when you go to another type, they're all going to have slightly different ratios that they have to be balanced for. And if we're not customizing them exactly, then we're going to have an imbalance. And God forbid I have everything set up for one of my low pressure systems, and this will never have enough to keep the clapper down, and it's going to have false alarms or false trips very frequently. Or worse, I suppose, would be that I set up my entire sprinkler header for conventional systems, and I expose these low pressures to triple to quadruple the amount of air pressure they might need. Individual air maintenance devices are a sore spot because they're about $500 to $600 each. And it doesn't look like a lot, but if I had a large mechanical room with 5 or 6 dry valves, and as a contractor, if I could save some money, it's something that you might see some inexperienced contractors doing, but it'd be your responsibility to catch. So we talked briefly about the pressure gauge locations. It's worth just mentioning about sprinkler heads. The restrictions for sprinkler heads, I've just cut and pasted the requirements from the standard uprights, listed dry pendants, pendants or sidewalls that are on a return bend, so that U-shaped piping arrangement, only if the area is still going to be above freezing. And then I can have sidewalls as long as I make sure I pitch them or I install them so they won't be trapped. So if we think about just a listed dry pendant, that's a suitable sprinkler head to be able to use. And the worry that I have is that if this was the branch line, I don't want to have any rust or scale falling down the tube and actually accumulating on the orifice of the sprinkler head. So there's 3 rotating sprinklers there. I can have a pendant sprinkler, what you're seeing here. I can have a pendant like this if it's installed on that return bend configuration. I can have an upright installed exactly as we see it there, just as a regular upright, because once it's connected to the piping, I won't have rust or scale or any debris going up. It'll stay in the lower part of the piping and it won't accumulate. And if I have a sidewall like what's being shown there, that's actually the similar sprinkler head to what's here. This is just a dry sidewall. I can have a regular sidewall installed. I just have to make sure it's pitched on a slight slope so that any debris that might be accumulating is going to be more inclined to fall backward or drain backwards into the piping. Now, in looking at these sprinkler heads that I've chosen, it's pretty unlikely that you're going to have these large discharge sprinklers, these K17s and that's a K32, but they're just kind of good examples for us to be looking at right now. If anybody wanted a bunch of samples of sprinkler heads, this presentation's available. If you've got your phone with you really quick, you can do the QR code for that. It's a QR code directly to the YouTube channel that has all of these rotating sprinkler heads. If you ever wanted to kind of get your geek on and check out a bunch, there's a whole library. There's about 52 of them. The need for specialized sprinklers are important so that we don't get that debris falling up and through. I like to think that spotting a dry pendant sprinkler is pretty easy to do. They'll have a larger portion that joins the actual branch line that's sealed. Of course, once it's installed, you wouldn't see that sealed area on the bottom of it. But at the upper portion, you should see a small little air hole. And that air hole is to allow the pressure in this chamber to equalize at all times. So these dry pendants or dry sidewalls, this is just open atmospheric pressure, but from here to there, there's a link that is held back in place by the sprinkler head. So when the sprinkler head finally operates, this link drops out of the way, and way in the tip, we'll have that seal break away and allow water to flow through. So while there's some obvious things about the piping arrangements are important, but if we don't also balance it with the correct selection of sprinkler heads, we're going to have some significant problems also. And that might be more for the plans review folks that are here, but even when you're doing a site walkthrough, it's something really important to check. You're the kind of last line of defense in system acceptance. And if a contractor's made a mistake, we really need you to find it, which is going to sound like a little bit of extra pressure, but I'll explain why later on. So dry systems have water delivery requirements, and a lot of people just have it in their head that a dry system has to trip in 60 seconds, right? If it doesn't do 60 seconds, it fails. And that's actually not correct. The requirement is that if it's a light hazard, it has to trip in 60 seconds. It has to get water from the valve to the sprinkler head in 60 seconds. For a light hazard, so nursing homes, churches, you can think about all of your light hazard occupancies. But as things become a little bit more and more hazardous, that time starts to change and can go as short as 40 seconds. And if you're dealing with a residential dry system, it's actually 15 seconds. There are now residential dry systems that are available. So the best way to do these is just to do a simple performance test. Going into it, you need to make sure that the inspector's test arrangement has been done correctly. Like I was saying before, that valve located right at that location would be optimum, and that will capture your 60 or your 40 seconds, depending on what the individual hazard might happen to be. For the amount of dry system tests and commissioning events that I've done, I prefer to do these twice. I would prefer to have a sight glass located at the most remote sprinkler head with a technician or someone up there giving us the indication of when water travels past that sight glass. And then as it goes all the way through and discharges, that's just the byproduct of the full trip test. So if I have water through the sight glass right there in 60 seconds for a light hazard, I'm good. If it continues to take another 5 seconds for the water to travel all the way to the outside where I can see it discharging the building, please remember, it's the most remote sprinkler head. It's not when it's exiting the building. The test configuration, the test apparatus, the sight glass or the inspector's test connection here has to have that restricted orifice that is the equivalent size of the sprinkler head that's within the system. And then this piping, if this is all 2-inch piping of the branch line with a K8 sprinkler head, the test valve has to have the restricted orifice equal to what a K8 is. And I would highly advise any contractor to continue that 2-inch piping all the way out the building. What we're trying to do as contractors is get the water and the air to that inspection point as fast as possible. having larger branch lines and then throttling it down to 1 inch is really kind of short-sighted, because you're putting that restriction and you're going to have unnecessary additions of time from that choking point from 2 inch to 1 inch. But that has to be there. And please remember, if they've done it, what you've seen in the photo, it's not wrong, but what they're doing is just adding some additional lengths of pipe, and that could increase the discharge and trip time. And if they're able to satisfy the trip time requirements, like what you're seeing here in 35, 40 seconds, and they have this arrangement, great. If you're there doing a test and they're bumping on 60 seconds almost every single time, passing on that tip would be reconfigure this as quick as you can and start taking your measurements from there. When I do a class for any NFPA folks, what I try to say is, if you go that route and have the inspector's test up at the most remote sprinkler, which we're really required to do the test there. If it tests out there at 45, while everybody is there witnessing it, do another test at the valve location as the water goes outside. And if you get it up in the air at 45 seconds and then it discharges out the building in, say, 55 seconds, maybe on all the annual inspections, as long as I keep hitting 55 outside, then I don't have to send somebody up a scissor lift to do it every single time over and over again. If I can continually hit that other value, because if it's hitting outside at 55, it should still be hitting 45 in the building. Okay. Another question was coming through is, should there be multiple inspector test valves on a dry system? If there are multiple dry systems, yes, every single dry system has to have its own individual inspector's test valve. If there is only one dry system, there should be only one inspector's test valve at the farthest part. They might employ some additional drain valves throughout the system, but a drain valve is not the same as a ITV most of the time. The ones that I have at the school, they're combination valves and they're a little bit more money, but for the most part, they're going to be way off on the distance to make sure we can do these things correctly. Okay. The oh Jesus moment or oh God moment, whatever your faith is when you're doing the system design and you're doing that final commissioning test and you do a test and it's, oh, it gets 65, 70 seconds, let's go to 90 seconds. Just based on what we've talked about right now, if this was a conventional dry system trip time at say 90 seconds, this is a great application. While it might be a bolder move to say, if this conventional system's tripping at 90 and there's no way I can kind of fine tune that, maybe I made a pretty substantial engineering blunder and my system is just bigger than I expected. This is a great application to say, I'm going to take this one out and replace it with one of these other low pressure types. And there's a great chance that you'll be able to, with just replacing the system valve, get your trip times to respond within what the requirements are. It's a pricey change, but it's a heck of a lot easier to do when there's a deadline coming down the pipe. Matt's comment about an accelerator. Accelerators and exhausters are sort of two different things. An exhauster, they don't really exist anymore in new construction, and they're not available from any manufacturers anymore. An exhauster was something that was put on the far end of the system that when there was a system trip, it would help to exhaust air out also. Exhausters were prone to malfunctions and just maintenance headaches. And with a different approach, the transition has been to an accelerator. And I think our terms in the world of fire protection are really straightforward. What does an exhauster do? It exhausts air. What does an accelerator do? Well, it accelerates the system, but it does it in a different way. When an accelerator detects an air loss, it doesn't just dump that air to atmosphere, it pushes it into the valve to make it trip faster. And I've got a couple of illustrations I'll show you in a few more minutes about that. But this trip time, those are all things that a good contractor, a good designer, good consultants all should know about. They might have, as we're allowed to do, you can use a calculation program that will simulate how quick your system will trip. But I'm a big fan of getting the system installed and doing a practical test. And if this doesn't work, try the route of an accelerator. If that doesn't work, then you might be left with no other choice but to replace the system. So the system sizes, we have to have water within 60 seconds. I just mentioned that, or dwelling units, 15. There are maximum system sizes, 500 gallons, 750 gallons. If I have one of these quick opening devices, which is what an accelerator or an exhauster really are. But if I can meet the delivery times, then the system size thing goes away. Okay. And here's just another illustration of what an exhauster might look like. It just had a small diaphragm inside the valve that it detected a pressure loss. And when that pressure loss was enough, it also opened almost as like a sympathetic sprinkler to have that trip faster. These larger exhausters really don't exist. And now we're dealing with an accelerator. And as I was mentioning, when that accelerator senses a pressure drop, it operates, and then it takes the air pressure from within the system and it fires it underneath into the intermediate chamber and helps the valve pop faster. So it's mechanically helping to overcome that pressure differential by putting the air underneath, and it'll pop it up. Okay. So Dan, I'm just checking yours. Does an accelerator have to allow water to the motion remote in 60 seconds? Yeah, it tends to be a design blunder. Can systems deliver water in excess? In super rare conditions, if the building is small enough, I'd have to walk Dan you through individually those parameters. But the broader context of these requirements are what we have to be aiming for. I've done that myself a couple of times where the system, piping got reconfigured and it was right on that cusp and there was a change. Adding accelerators, changing out the valve is one item. My buildings were too big to try to work around that exception. But I don't have the time now, but we'll go over that another time, or just you and I can chat. Okay, so I mentioned it before, the valve rooms have to be lighted and heated. I would prefer them to say lit and heated, but this little space heaters, locked door, doesn't even have to be a locked door. It could be just in a heated room. The whole idea of having it locked would be more to secure the supervision of the valve to make sure that it wasn't being tampered with, but you don't need to have that necessarily happen. So just keep this room nice and toasty warm. Heat tape, heat tracing, that doesn't count. The air line for the systems, dependable continuous source. The sizing of air compressors does tend to be a bit of an issue because they've got to be able to refill the system in 30 minutes. And if it's a refrigerated system, we can go up to 60 minutes, but that's where we have the idea about going to Home Depot and buying a Husky or a Princess Auto air compressor. That's where it tends to fail if it can't refill the system in a high enough capacity. Okay. I mentioned the air maintenance devices. Each one has to be dedicated. This requirement is not really mentioned in the standard. What it's mentioned in is within the actual manufacturer's literature. So when you pull up the valves from Reliable and Globe and whoever they are, individually it'll say there. Now there's not a requirement that the Tyco valve has to have the Tyco air maintenance device, but it just has to be a listed a listed air maintenance device. Okay. Good. What you can see on screen is just a conventional dry valve. I'm making that assessment because you can see that the valve body looks to be a lot bigger than the actual pipe itself. So to see a conventional system with 20, 25 pounds of air pressure on it would not be unusual. But with the information that's right on that hydraulic placard, we should be able to pull up from the Viking website on our phone what the ratio is, and you could check very quickly, there's my city pressure, and to see if that's been done correctly or not. There is no, it's always 4-to-1, it's always 5-to-1. They're all individually tailored. The fact that this air compressor is mounted on the riser, are there any pros and cons to that arrangement, do you think? So I guess a pro to this would be that it's taking up less space. I've taken that thing off the floor and I've mounted it directly on the riser, and maybe I might have a little bit less pipe connecting the two of them together. That's a possibility. A con would be that when this air compressor turns on, it's going to shake that riser ever so slightly. So any of these joints that are within the system, that vibration is actually going to lead to a potential air loss. So it's kind of like when that kicks on, it's going to replenish the system to its normal required pressure, but it's going to also weaken that seal, and over time there could be an actual air loss at a grooved coupling because of that vibration over and over again. I suppose the other obvious one would be just that if you've got an office on the other side of that block wall, it's going to get really, really loud, and most people aren't going to want to have that happen just because it's going to make so much more noise. If you have to replace the pipe, yeah, there's more work to do, 100%. I'm not a fan of these riser mounted ones. I worked for companies that was their bread and butter, just from a space issue. What I do find, again, I'm not promoting one brand versus another. Going with an actual listed air compressor does tend to make them quieter, run a lot better. The one air compressor that we have in our lab space, it's designed for to be the quietest, one of the most quiet on the marketplace, and it might turn on while I'm talking and you'll barely even hear it. And it's a 40-gallon, 2.5 horse air compressor. It's a monster. But the decision for what components to use, it's economics, right? Some contractors might be specified to use one brand, one type, based on the owner's previous experience with wanting to have perhaps a different type of reliability with the component. Maybe it's going to be a little bit quieter, but if it meets the minimums, right? Going by NFPA 13, if it meets the minimum, yeah, go to Grainger. It'll be, go to Grainger, go to Princess Auto and get your cheapie, and as long as it fills the system in 30 minutes and has a air maintenance device that's correct, that's it. Dry pipe systems within the context of 13 is discussed just in chapter 5. Okay, so chapter 5 tells me the bare minimum requirements, which is what NFPA is the minimum requirements for what a dry system has to include. And I've done just a quick little screenshot of, there's where dry systems start, and we've talked about pressure gauges, sprinkler heads, the system sizes, the discharge times. Like, we're talking maybe 6 pages of content. So when you're trying to get advice or get guidance for, has this been done right? Chapter 5 is going to be your starting point, and then you're going to need to go up into higher chapters of the standard for the actual physical installation. Now, I've got my standard here because, contrary to popular belief, I don't sleep with this under my pillow. But when we get into using the 2019 edition, chapter 16 tells me more things about how the systems have to be installed. And if you have a chance to get to the 2019 edition sooner, it's laid out a lot better and you'll probably enjoy using it more. But if you enjoy using NFPA standards, you should probably start coming to the support groups that I host on Thursday nights in Newmarket. Just as a heads up, it's a nice group. We really talk about some high pressure topics. It's the best joke I got, and they're not even good. So dry systems overall do have to have some other things added to them within the broader system. So when we think about, the fire pump, is a fire pump for a dry system going to be the same? 100%. Is the underground loop for a dry system going to be the same? Sure, 100% it will be. The dry system is really going to only change at that interface from the control valve up. How it integrates with the building we all know that each sprinkler system is going to be customized for that building. And that's where chapter 16 is really going to come in to make sure that I am more familiar with the slope of all these branch lines, that I'm aware of the style of sprinkler heads that I'm allowed to use. If I was looking at this illustration a little bit more in depth, it looks like they all have pendant sprinkler heads installed, and that would be suitable if those were all dry pendants. It doesn't look like they're on those return bends. So, you know, not every single sprinkler is suitable for every type of application. And not every single sprinkler, for what it's worth, just to time out on that for a second, not every single sprinkler head is suitable for every type of occupancy. So while it might seem I can use uprights and pendants and sidewalls anywhere, there are still restrictions based on the occupancy as well as the system type. On the drain side of things, most dry pipe systems are still going to have a main drain. This would not be a main drain that you would see on a typical dry valve itself. Again, if you switch your view on the camera, the main drain for a dry pipe valve is going to be below the clapper, so that once this clapper and this dry valve trips, these all lock in an up position. So they all lock open, and then the main drain will allow me to drain out all the water from within the system. And that's the same for all of them. The reason why all these systems are, all the dry systems lock open, is so that if there's ever some type of surge, that it locks and stays open, and it doesn't give a chance for the clapper to slam back down again with water sitting on top of the clapper, and that will essentially make it non-operable. Right? It's not a good idea at all to have any accumulations of water on the top of that dry valve, because we're changing the characteristics of how it's going to operate. So there's 3 drains in this photo. There's just a typical main drain, which I just showed you on the valve behind me. Then there's these auxiliary drains, and then what you're probably more used to seeing is these drum drip arrangements. So when we're doing any type of maintenance work on the system, we would normally want to have the system turned off. You know, all the checks and balances have been done for permission, contacting the insurance company and the AHJ. So let's pretend that I've done all of that. You know, when I look at an auxiliary drain compared to this drum drip, they're both still auxiliary drains. But this one, when I take the plug out of the bottom of it and I open it, is going to allow large volumes of air to be dissipated. And if I'm not paying attention, I could actually mistakenly trip my valve by just trying to do some regular maintenance on the components. If I look at this drum drip valve, it's designed a little bit differently. And I'm going to show you one in just a second here. This lower valve is left closed, and this upper valve is left open. And when this is installed at a low point of the system, what should be happening over time is condensation will be accumulating, and because it has an opportunity to fall down with gravity, this valve being open, the water is going to pass through and remain in this collection chamber. Now, this is a huge thing that has to be done through proper maintenance, but by operating these valves in the right sequence, the water will collect within this lower portion of the drum drip. And when I'm wanting to get rid of the water that's collected in my system, I would close the upper valve, open the lower one, and then that lower chamber, all the collected water will drain out. We want to do it in that sequence. So the lower valve, when I get there, is going to be closed. The upper one will be open. I close the upper, open the lower, and that will allow any of the accumulated water out. But what it won't do is allow excessive amounts of air to go flowing through the system to inadvertently trip my dry valve. So you can use a drum drip assembly on an active system. The entire intent is that I can cycle through, opening the top one, opening the bottom one, and get any accumulations out. The heat tracing of drum drips, it's not a requirement, but if your system is regularly accumulating high volumes of water, I can see where a lot of building owners would want to heat trace this, so that if, you know, for whatever reason, the system has a habit of just sweating a lot, Yeah, a lot of the airports do them as a precaution, but it's more your choice. It's not a requirement at all. The requirement is that you do the maintenance on those drains correctly. So my rule of thumb is that if I send a technician to do this drum drip and he or she does the sequence of open and close and they get 5 gallons of water and then they walk away, well, no, you're not done. Like, you do it until you get no more water out of it. So if I get tons on the first day, I'm going to go back maybe after lunch and do it again. If I get more and more water, then I might just have to have somebody there working that drain until I get any of that accumulation out of the system. If on the second day I get, half a gallon or much smaller amounts, chances are that I've been able to purge all that excessive water out of the system, maybe from when it was last tripped or when there was the last maintenance being done on it. But those valves, they've got to be hit. There's no frequency other than to make sure that they're maintained properly, and properly is no accumulations of water. So I'm going to swing over all the way over to this particular valve, way over in the corner. Okay, way over in the corner is a drum drip assembly. As I walk all the way over to the lab. So you should be able to see this drum drip assembly. It essentially works on the same concept. It's just a little bit fancier. This one just has a small little red cover on it to provide some guidance to any of the consumers about sort of what sequence to operate things with. Again, not a sales pitch, but this one actually works out to be a little bit more unique. This has a water detector built into it. So when this is set up correctly, as water accumulates in that, there's a little 9-volt battery that sends an auto alarm if it does have accumulations in it. So Dan, that's a really good alternative to potentially getting away from heat tracing, is to use some that are electrically monitored in case there's an accumulation that's gone unnoticed. I don't want maintenance people to only listen for the beep, but it's a another layer of protection for us, I suppose. So let's just pretend this was an active dry pipe drum drip. This lower valve would be closed. This upper one would be open. So I'm just putting this in the open position now, just for our demonstration. But it's in an open position. Water's now coming and collected in this portion. If I were to open this lower valve, I'll be exhausting all of that air pressure within the dry valve, the dry piping system, and I don't want that to trip. So I've opened this fully to let water to accumulate. I'm going to close it. Now the air pressure is being held back by this upper valve. And I'm going to get a smaller amount out of the bottom. Now it might take me a few times to cycle through. I'm just going to zoom out a little bit more so you can see the water hitting the ground. You can change the view of your perspective in Zoom to capture this camera a little bit better. Right now, if I open the upper valve, I'm taking direct system air pressure out, and that's going to be kind of dangerous. I don't want it to trip. Close the lower, open the upper. Anything that's through the rest of this drain system should have fallen down by now. Close it, open it. And if I was a maintenance person and I'm getting basically a tiny amount of residual water left over, just gonna let it drain out, close it, open it, and I might cycle through this a couple times. And I'm pretty much not getting any water now. So the system at its auxiliary drain is completely empty. And I put that back up. Leaving it like that would be ideal, because we've got the one that's audible. Lab environment, that's going to go off real soon. So I'm just going to leave this closed just for my own classroom purposes. But the sequence of operating one of those drum drips is super, super easy, but it's only going to work well if the maintenance people know what they're actually doing. Okay. I think we're good on all those questions, which is great. Often neglected and impossible to detect on an existing system is that the groove couplings for dry systems should be a little different. What you're seeing here is a grooved coupling that should be installed on a wet pipe system. The groove coupling that is for a dry system actually has a larger rubber ridge right in the middle of that. And that larger rubber ridge in the middle, which is hard to say, that rubber ridge is designed to prevent this little part of the groove coupling having any water accumulate in it. And we want to prevent any accumulations of any type of water in the system. So if you're ever on a job site and you have a chance to see how they're assembling and building the system, it never hurts to check the groove coupling. Whether you think that's part of your responsibility or not, I'll leave you to worry about that. But that coupling in the middle has to have that rubber ridge, or there's going to have multiple freezing points in the system, and it's probably not going to work out well for the contractor. In a dry system, because we know we could have anywhere from 60 seconds to 40 seconds of a delayed response, when I'm doing my design, what I have to make sure is that I allow for the delayed response from sprinkler head opening to water getting there. So when I'm doing my hydraulic design, I have to allow for a 30% increase of my remote area. Now, these are more technical terms perhaps for some of you, but when I'm doing that design, if I'm dealing with, say, like a light hazard sprinkler system, when I do my design, I have a certain discharge density, so much water that has to come out of each individual sprinkler head. And I have to do my calc over sort of the theoretical worst case scenario, a big area that's been tested with that density and that operating area to be successful for fire extinguishment. For a dry system, I have to have a 30% increase. A lot of people will call it a penalty, right? Because of that delayed response time and that delayed trip time, you would be taking that 1,500 and you increase it by 30%, giving you 1,950. That's an increase adjustment. If I had sloped ceilings or other building features that are also having multiple increases, they're all compounded. So if I have a sloped ceiling, that's going to delay the speed at which the sprinklers operate because heat's going to travel past or potentially travel past the sprinkler. There's a 30% increase on top of that. So when we're dealing with these, I think for the most part, we can understand that there's going to be a delay and we have to compensate for that delay by going with this increase. The thing that I find the most challenging is that NFPA 13 tells me kind of quickly how to design them. And then this is never looked at again. And I'm serious. Once the building owner takes possession, they transition out of the requirements of NFPA 13, and now we get into the requirements of NFPA 25 or the Ontario Fire Code, which we'll talk about. But I want everyone to kind of remember that 25 is the minimum requirements. It really tells me when to do an inspection, not how to. So this is why I have these two different illustrations shown, or these two different graphics, that this will tell me to do it monthly, quarterly, annually, but it doesn't tell me actually how to do it. The how-to is going to come from the manufacturer's instructions. So for the Reliable, the Tyco, any of these, they're all going to have their own little tips and tricks, like 17 re-steps. We have to follow those instructions. Those have to be sort of switched between back and forth. Okay, so I just mentioned this. 25 is really just a minimum requirements for periodic inspections. What it really is just, it's a guidance document that is wear and tear driven. And what I mean by that is I'm looking for rust. I'm looking for things disconnected. I'm looking for, a crack in the coupling. I'm looking for a hanger that's missing. It's just to determine what's physically there is still there and looks to be operational. As we continue down, it says inspections are not design evaluations. A sprinkler system inspection following 25 or OFC is, does this look like it's going to work? And you do the obvious ones, valves being open, pressure gauges appear to be in the right positions, but we're not checking to see whether they've done anything else. It's not an inspection of a sprinkler system is not the same as the inspection of an occupancy. This one comes up all the time, like, well, they converted the warehouse from shelf storage to rack storage. Is this sprinkler system adequate? 25 inspection is not designed in any way, shape, or form to capture that. So please remember that. It's checking for bad couplings, it's checking for accumulations of rust or debris, and that's the extent of it. Okay. The adequacy of the design is not ever really brought into question during that 25 inspection. It's, is it there? Is it still attached? Is it still hung from the ceiling? Does it look like it's still going to work? And that's it. We're not checking distances off walls. We're not checking the adequacy of design, whether it's the right K factor. We're not looking, as you can see on the right-hand side, you know, whether this combustible concealed space is protected or it's not protected. That's out of our mind. Okay. And this is why, if I go back to this one for a second, when we get out of NFPA 13, we are presuming that everything's been done right. So if you're on the inspection side and you've given occupancy and you've granted permission to occupy the building, you've gone through all your checks and balances and you've said it's okay, I don't get to touch 13 ever again. I'm only going to be stuck with 25. And I deal with more NFPA stuff than OFC, but we don't get a chance to go backwards very often, or if at all. So in the province of Ontario, who's qualified to do sprinkler system inspections? Anybody want to hazard a guess? In the province of Ontario, who's allowed to do inspections? Okay, so we've got two answers and they're both right, which is fantastic. So what's the periodic interval, and then College of Trades? So Chris, College of Trades doesn't exist anymore. They've now been changed to Skills Ontario, Skilled Trades Ontario. Same responsibilities, same licensing, same everything. So you're right. And Dan, you're right also with the inspection interval is specialized in Ontario. If it's less than 6 months, the building owner can do it, with a couple exceptions. And if it's more than 6 months, then it has to be someone who has this qualified credential. Qualified in Ontario is someone with a 427A certificate. So someone who's completed the apprenticeship program. And if the inspection interval is short enough, I'm going to use the word civilian, but a layperson could do it, right? A daily check of a gauge, a daily check of a valve being open, I wouldn't have to be qualified to do that, or exceptionally qualified. I'm making sure that the valve is still in the open position, but that's the extent of it. So 25 doesn't specifically say who is qualified, and OFC doesn't even really talk about it, but it's sort of as accepted as a best practice in Ontario. It's legislated in Ontario that it's going to be a 427A person who does the more the larger work, the ones that are on those intervals that are a little bit further apart, which doesn't mean you could do your inspection once a month and change the requirements. If the standard says annually and it should be done by a 427A person, please don't try to find the loophole that if I do this inspection monthly, that I've beat the system. They've tried it and they've lost. Okay. Right now, we know that the biggest failure of sprinkler systems is by valves being shut off. It's embarrassing to think that we caused the majority of our own problems, but as it is now, that valve being turned off is going to cause the most significant issues that we have, and I see it all the time, where an inspector shut off a valve to do the backflow inspection. They bypassed it at the alarm. They, goofed around in the alarm a different way and disabled that supervisory switch, and it goes back in service and nobody knows any different, and then the valve has been left closed. Those stats are kind of embarrassing to think about, that it's us that are doing the things wrong, doing the items wrong rather, but it is still a stat, might be 10 years old now, but it's still as accurate as it was from when it was published. For those of you who don't use NFPA 25 very often, and NFPA 25 covers everything water-based. So you're going to get all of this great stuff: sprinklers, standpipes, underground pumps, water storage. You can read them just as well as I can. But sprinkler systems are covered in 3 or 4 different areas, but I'll talk you through that. The big part is Chapter 5. And when we're talking about sprinkler systems, this is from basically everything here up. That's what Chapter 5 is going to cover. And when we get into Chapter 13, it's going to cover from here down. And they've done that because there's a lot of common items, right? The inspection requirements for this control valve and this pressure gauge, the inspection requirements for a lot of that are pretty generic and pretty much the same for whether you had a fire pump or a water tank. You still have those same items. So for us, we often have Chapter 5 to deal with, and then Chapter 13. And knowing that it's a when to document and not necessarily a how to, the inspection frequencies, the testing frequencies, and then the maintenance frequencies are all described to us in some sort of cute little tables. Now you can't read that one, so I'll pop it into another view. Thinking about the requirements of a dry valve, which is what this discussion is all about. The requirements for a dry valve are actually found in the common components and valves, way up in Chapter 13. So a dry valve's got to be done external inspection every month, an internal inspection every year. Strainers basically take all the trim apart and have a good look inside every 5, and then check for low temperature alarms every year. It's always worth jumping into the actual references off to the side, not sort of exclusively looking at the table information, but I want you to see kind of where this basic information lives. And this is just for the inspection frequency. Same thing for the testing, the test valve. We're doing air leakage every 3 years, checking the priming water quarterly. Dan, you made a comment about that earlier. Low air alarms are annually. Quick opening devices, we're doing those quarterly. Trip tests annually, and full trip tests every 3 years. So the difference between a trip test and a full trip test is simply I'm trying to minimize the amount of water that I'm incorporating or allowing into the sprinkler system. So annually, I do a test that has this valve virtually closed so the water won't go all the way through. And the intent for a basic trip test is that this is just about entirely closed, still gives me pressure, but not the flow. And when I actually operate the system annually, it's exercising the dry valve. It's going to trip, it'll pop, but it won't send water large scale down through my building. And I want to kind of keep the amount of water in the system out. So those on an annual basis using NFPA 25 is what the deal is, or what the minimum is, I should say. Full flow trips every year, or every 3. Sorry, it's getting longer in the day already. Every 3 years, valves fully open, and we're doing this full commission all the way to the end. Okay. So there are some subtle differences. Galvanized piping, Dan, is allowed. Galvanized piping, depending on whose white paper you read, will be a benefit to reduce corrosion or a detriment to reduce corrosion. I've read enough white papers on both of them that corrosion inside the system is not exclusively going to be reduced by a pipe coating. It's more about what's in the water we're putting in the sprinkler system. I've got a couple of friends who work in California, and they're trying to come up with almost like a rinsing solution that you fill the system full of their proprietary chemical mix, and it helps to prevent mick from starting or corrosion to start, and then you drain it back and only fill it with air. But there's really not a perfect approach for that right now. Is it true that dry systems should or should not be tested during non-freezing months? I would not trip a dry system if it was going to be anywhere close to being freezing. It's just unnecessary. You've got, for us, 8 months maybe 7 months, maybe 6 months, depending on how long the winter goes for. But we've got a 6-month window to do a full trip in warmer weather. I would be really hesitant to do a full trip in colder weather, because unless my maintenance crew is really on the ball and I can guarantee to get all those low point drains, I'd be a little bit nervous about that. Again, thinking about now you go maintenance. So the inspection frequencies are there, monthlies, annuals, pretty straightforward. Inspections are purely visual. So my hands are in my pockets and I'm making sure that that's open. There's no physical damage on the outside of this. Even though there are elements to this particular valve where I can reset the valve externally, the faceplate's got to come off. You've got to see inside the valves. The external resets that are on some of the newer valves are not meant to replace taking the covers off. And I will say to every single building owner, get a little bit of red paint and put a little bit of paint on all edges of the bolts, so that when you're ensuring your inspections are being done properly, none of that paint should be there, because they've used wrenches and sockets to pull the cover plates off to look inside. If the paint's still there intact, then they're not doing their due diligence properly and they're fudging stuff. Okay. Even as an FPO, maybe you guys could suggest, you folks should suggest that to building owners. This external reset, the external reset that's on the back of that, actually it's right here. They all have them, but those external resets are to facilitate when the valves are being first set up and installed, not on an ongoing basis to make the inspector's life, make his or her life any easier. We also have maintenance on quick opening devices, so they have to be maintained annually, which means, following the manufacturer's instructions. They might say to here's one, they might suggest taking it apart, cleaning it, blowing air through, taking strainers out, but it's going to be following the manufacturer's instructions. It just says, hey, do it every year. And these are different examples. There's a much older accelerator. This is one of the newer styles from Reliable. Again, I don't care about the brand. What I want is it to have been inspected on a regular basis properly. This is a little bit concerning because there's 0 air pressure, but the accelerator is reading some air. So the more you look at gauges, the more you can kind of use them as a guide for whether your system is healthy, if you will, which is why I think that obviously having good gauges that are calibrated or no more than 5 years old is a necessity, but not everybody catches that either. Okay, so the ITM for dry systems, again, if the room was full of people, I'd probably go through one fully for you. I've got a video I'll show you in just a second. But the basic ITM requirements are that we're hitting this, checking the priming water correctly. So there is a certain amount of water we want to have in the body of the valve, but not an excessive amount. Much like the accumulation of water at our auxiliary or at our remote points, water could still accumulate in this riser. So by checking the priming water quarterly, we're trying to make sure that there's not an accumulation of water that's gone here versus one of my auxiliary drains. All right, but the intervals are all there. That's just a different way of showing it to you. So this video walks us through the elements of a trip test. I'm going to play it. This is directly from NFPA. I'm going to play this video for you quickly while I catch my breath, and then we'll keep going. Sorry about that. When I shared the screen, I didn't share with audio. So I'll do that right now. And we'll play it one more time. Thanks for letting me know, Vince, if there's any issues with the screen this time, let me know also in the chat.
Dave, can you open up the inspector test valve for system 3 parking garage?
Trip test a dry pipe system every year. Partially close the system control valve to prevent flooding the system and shut off any quick opening devices. Open the test valve to release air pressure from the system, or the low-level drain valve in the case of systems without priming water.
Okay, opening inspector's test valve, system 3, parking garage.
I marked that at 4:32 and 29 seconds. System 3 is tripped.
When the dry pipe valve trips, close the system control valve. Drain any water that may have condensed in the system. This completes the yearly dry pipe trip test. Once every 3 years, dry pipe systems need a full flow trip test, with the system control valve open and any quick operating device in service. A security representative bypasses the audible alarm and will record the time it takes the alarm system to activate. Record the system pressure. The inspector's test valve is opened completely and testers start their stopwatches. The tester at the dry pipe valve notes the time and pressure at which the valve trips. The tester at the inspector's test valve notes the time at which water flows. When clear water flows from the inspector's test connection, close the main system valve and open the main drain and all low point drains to completely drain water from the system. When the system is drained, remove the cover plate from the dry pipe valve and verify that the clapper is locked in the open position. Make sure the clapper is clean, then reseat it and replace the cover plate. Follow the manufacturer's recommendation for resetting the dry pipe valve. Even when the system has an external reset device, take off the faceplate to verify that the valve has reseated and the test water has drained.
And the test water is drained out properly. So the issue I was describing with the automatic resets, it does drop the clapper. Great, awesome. But what it doesn't do is let you look on the inside to see if there's any debris accumulated through here, which is most certainly going to happen. Dry systems are just famous for large accumulations of dirt, debris, sludge, and just nasty stuff. This header, up to a couple months ago, we weren't flowing water on a regular basis in the lab, had about 2 inches of a thick sludge across the entire bottom of it. So that's going to get flushed into the dry system just by the system operating, and over time, that stuff is going to foul up these dry valves significantly. Okay. Vince, Dan, you made a comment about the report times. NFPA 25 just says that you report the trip time and water pressures. You make a report, you leave that on, near the riser in your annual reports, and you document all of that, and then you just kind of put it off to the side. So what is missing in that descriptive is that if you notice that your trip time was, 90, not 90 seconds, say your trip time was 55 seconds, but it had been for the last few years 35. OFC says if you see a 10% change in trip times, that triggers more things to happen. NFPA 25 doesn't, and the expectation as a best practice is I'm going to see my times from this year, my times from last year, and the expectation is that's going to prompt you to do more of an investigation, but it's not specifically mandated in the language like it is in the Ontario Fire Code, which is about the only time that I'll ever say that OFC for one little part might be better. Right now, we're dealing with a 3-term for system impairments. Impairments, critical deficiency, and non-critical deficiency. These get mixed up all the time, so I'm going to talk about them for a couple minutes, and we're getting close to being completed. Okay, so system impairments, obviously, it's where there's going to be a high priority something is going to cause there to not function properly, for sure. That's what an impairment is. From a deficiency, there's something in the system that's going to, potentially and adversely impact the system performance. And I think potential and adverse used in the same sentence is a little bit, a little bit odd. So we really have critical deficiencies and non-critical deficiencies. So impairment, the system will not flow water, it will not function as it was intended. A critical deficiency is that there is, if not corrected, it can have a material effect on the ability of the system's performance. It will. Non-critical, a sign missing. And it's probably the easiest way of describing it. Hydraulic placards being missing. Is that a critical or a non-critical deficiency or an impairment? I'll open it up to all three of them. Is a hydraulic sign being missing, or, is this sign being missing a critical, non-critical, or is it an impairment? Sign being missing is a non-critical deficiency. Fire pump being turned off is an impairment. A critical deficiency, sprinkler head that's been painted would be probably my easiest next suggestion. Okay. This terminology isn't necessarily described in OFC, but any contractors that are inspecting to 25, that's likely the vocabulary that they'll be using. As far as the inspection process goes, when I talk to contractors specifically, there's always this question about, well, the building owner is going to do their inspections of the valves and the gauges, all those shorter frequency ones on their own, and then we're going to do everything else. And I would normally say that, look at, like, you better check with the building owner to make sure that the services that they've contracted you to do, you mutually understand what they really are. And then that meets the requirements of what the state or province is requiring, because the state or province in Ontario, we're a little bit unusual. You go to another province and they might not have this ability of saying 6 months and less, the building owner can do it. The insurance company might say, forget it. We don't want the building owner doing any self-inspections. You have to hire it out or have a qualified on-site, on-staff person, doing all that work exclusively. So the insurance company might say, nay. The manufacturers might say it has to be a qualified person, and that might not be the guy who runs the maintenance department. This responsibility, and again, I'm thinking more about contractors' perspectives versus building owner perspectives. The building owner is going to hire ABC Fire Protection to do the inspections, and they're expecting that they're going to get like a bill of health from that contractor, right? Oh, my sprinkler system was fine. And sort of like when you bring your car in to get the tires rotated or oil change, some people will think, well, when I drive out of the shop, that they've done a look around to make sure everything else is okay. Probably not. So we have to make sure that the building owners are really aware that they're getting exactly what they agreed to pay for. And when they start to get cheap and start to go for low bid or low contract, they might be accepting a lot more responsibility overall. And this accepting responsibilities is kind of a dangerous spot, because they might not fully appreciate that it's theirs, their building, their system, their problem. And while they might have contracted somebody to do it, ABC Fire Protection or Pugsley Fire Protection, the reality is that I'm going to do what I've been paid for. And if in my contract it says annual inspections only, there can be a big contrast in what I'm, as a building owner, what I'm expecting to get versus what I'm actually paying for. And then when you guys come around for a routine inspection, there can be a pretty substantial misunderstanding also. Okay, good stuff. As far as OFC goes, we know it's a Part 6 item. I'm pulling this up from the latest copy I downloaded last night. The compliance of sprinkler system inspections, NFPA 25 will be deemed acceptable. That's great. Other times, a lot of contractors will kind of just use the OFC for what's written. I was going to say the good or the bad of it, but I don't want to temper your impressions. In most cases, if there's an insurance company involved, they're going to say that it has to be done per 25. So while you might be at a little bit of a loss for an enforcement piece on some of the 25 items, their insurance company is probably going to be your best ally in those areas. Okay, so I don't think there's a lot of things that are different, but let me ask you as a group, for the time that you've been using the fire code, what is the biggest gotcha item or the biggest contrast? Where do you struggle trying to enforce OFC versus NFPA 25? It's an open question for anybody. Mic's on too, maybe, if you're gonna type a lot. Okay. So the fire code deals with change of use. NFPA 25 is absolutely mute on the subject, right? It's a good point. And you're walking in looking at it with the responsibility as an FPO, as an inspector, to look at the entire building, where 25 is just that one little system. So that's one part. There's going to be a contrast. Okay, so while a few more people perhaps type their responses, the requirements or some of the differences. Dry pipe systems have to be inspected every 15 years for obstructions inside the piping, where NFPA 25, it's every 3. Actually, they're inspected internally every year, right? When I'm doing this internal, but then there's a separate batch of requirements for internal inspections. And if I find something, I have to do a lot more. So, you know, this language is pretty loose and almost too far apart by today's standards. Priming water is done every 3 months. I believe in NFPA 25, it was done quarterly. So, you know, our intervals are pretty much the same there. Valves are inspected weekly, you know, sealed, locked, or monitored. That's not that much of a difference from 25. The parameters for the inspector's test, OFC versus 25 are pretty much the same. Trip tested annually, that was the same as before. Full tripped every 3 years. That's the same as what 25 describes. But Dan, I think this was where you were describing the contrast or the relationship between times and how we record it. OFC says if it's off by more than 10%, that's assuming all the records have been maintained the way that they should. Let me know how that goes. Good. Are there any other contrasts between 25 and OFC that you guys have come across? If there's one that anybody wants to talk about, by all means, just send me a note. I'll give you my contact information at the end, because there might be a worthwhile discussion trying to figure out one particular challenging area you're dealing with. Okay. So any questions? Hopefully my microphone's been on for a little while. If there were any questions, by all means, it's a great opportunity for us to have a chat even more. I guess the only commercial that I'll say as far as what we've talked about and what we're doing here, Seneca College is open for any municipal fire department to come and receive training at or to conduct training at. So whether it's in the fire sprinkler lab, which is what we're looking at right now, in the fire sprinkler lab, we can pretty much do anything for operate valves. We can flow sprinkler heads. All these are arranged to flow sprinkler heads in relation to lights and tons of stuff. We can pretty much do anything in here. Everyone, by virtue of being involved with a municipality, you're invited to come to the college to do any type of training that you would like, and that can either be co-hosted with myself or another professor. But the space is fairly robust in this one particular room, and you're all welcome to come and visit with us anytime you'd like. And that goes for the same for the fire alarms lab or our alternate fire systems lab. So if there were follow-up questions, let me know. Send me a note through email. Love to help you out. I'm local for many of you, and I have no problem swinging by and looking at stuff. I'm happy to help out. And otherwise, I think, Matt, I'll turn it over to you. now as he's quickly stumbling to find the mute. There he goes.
Yeah, I got it. Thanks,
Yeah.
Scott.
Good.
That was incredible. Thank you very much, Scott. Really, really appreciate it. Yeah, I just, if anyone has questions or anything like that, grab his info because Scott's a fantastic resource.
Thanks for that. Emails there, drop me a note. Otherwise, I hope to be able to see you guys at an upcoming event, especially the OMFPA ones, because we're going to be there in full force on a regular basis, and we're really happy to help out. And for all of the alum, when you're at an event, make sure you've got your challenge coin with you, or if you don't have one, see me soon, because I try to hand them out as fast as I can. I just have to be in person to do it. So we'll see you all very soon.
Thanks, Scott.